Hello everyone. In Calculus 2, we learned how to find the center of mass. Now we had some limitations because we can only work with one independent variable. So what we did was we took a region in the xy plane with the following boundaries, and we said the density will only change in the x direction. So if I slice up my region from top to bottom, the density would remain the same. So in order to find the mass and the center of mass, we first started with the mass, where we integrated the density times the area parameter, and that gave us the mass. Then when we said, what is this distance from here to here, that's the x distance. So the moment would be exactly the mass times the x distance. So we perform this integration. And finally, the moment to the x-axis, which we call mx, would be the y distance. But because we can't have a variable of y, instead we took the average of f of x and g of x because we said the density did not change, and we come up with this a little more complicated formula. Now when we finish finding these three quantities, we now calculate the x bar and the y bar to give us the center of mass, and we call that the centroid. Now let's suppose we have a region here, but x and y we're going to treat as independent variables, and so the density will change at every single point, and now the density is a function of two variables. So in order to find mass now, we do need a double integral. We're still setting up the area the same way we did with a single integral, except now because we have an integrand with two variables, the mass will turn out to be this quantity. Now, just like before, the moment to the y-axis is the x distance times the mass. So we take this, we multiply by x, and the y distance, we multiply by y. We couldn't do this in Calculus 2 because we had to only have one variable, but now that we've removed that restriction, we find this is actually a much easier quantity to do. Now suppose we have a three-dimensional blob here where the density at every point is given by this function here. In order to find the center mass now, I need to set up triple integrals because I'm not only integrating over the volume, I'm integrating with an integrand. I cannot do this with a double integral. So the mass will have the same form as before. I'm still using my integrand as the density, but now I'm integrating over the volume, and the dv indicates that I can integrate dx, dy, dz in any order that makes it convenient. Now, we have new names for our moments because the moment to the xz plane, xy plane, and yz plane are the specific distances. So the moment to the yz plane is the x distance. The moment to the xz plane is the y distance. The moment to the xy plane is the z distance, hence the notation. So when I perform this set of integrations, then I will find that x bar is simply this moment over m. Y bar is this moment over m, and z bar is this moment over m, and like before, my centroid, my center of mass, will be x bar, comma, y bar, comma, z bar. So really the only primary application of a triple integral in general is to find centers of mass. Because of the density, I have to do these as triple integrals every time.